Hello everybody, this is it. This is what I consider the hardest lesson out of all three math Regents courses. I can prove rectangles, rhombuses, and squares using the two rectangle proofs, the three rhombus proofs, and understanding that a square must have a rectangle proof and a rhombus proof, and first you must prove a parallelogram. This lesson is so conceptual that instead of actually doing stuff, I'm going to more just talk through answer keys, because if you don't have the basics down, there's really no point in you watching that. It's all about the conceptual. So let's start by making sure we understand how to prove a rectangle, rhombus, and square, and then we'll move on from there. So you need to know that to prove a rectangle, I need to first prove it's a parallelogram, and then prove one of the two rectangle proofs. A rectangle is a parallelogram with one of these or one of these. A rhombus is a parallelogram with diagonals perpendicular, diagonals bisect the angles, or consecutive sides congruent. And to prove a square, it needs to be a parallelogram with one of these and one of these. So I know I already did a lesson on this, but let's just quickly recap it. A parallelogram must be a rhombus when it has one of the three rhombus proofs, diagonals perpendicular. A parallelogram must be a rectangle when it has one of the two rectangle proofs, either a right angle or congruent diagonals. A rectangle must be a square when? Well, for it to be a square, it needs to be a rectangle and a rhombus. It's already a rectangle, so it needs a rhombus property. Consecutive sides are congruent. A rhombus must be a square when? Well, again, it needs to be a rectangle and a rhombus. If it's already a rhombus, then it needs to be a rectangle. If you're looking for one of the rectangle proofs, it has a right angle. A parallelogram must be a rhombus when you're looking for one of the rhombus proofs, that is diagonals bisect its angles. A rhombus must be a square when? Well, if it's already a rhombus, it needs to be a rectangle, and that is diagonals congruent. So you really have to understand the concept of how to prove each shape. Once you do, we can take a look at the mini proof version of this. In order to prove a rectangle, we need to have a parallelogram, which we do, and then one of the two rectangle proofs. In this case, I have diagonals congruent. Once I have a parallelogram with diagonals congruent, I can say it's a rectangle. A rectangle is a parallelogram with congruent diagonals. If I want to prove that it's a rhombus, I have to prove it's a parallelogram first. It gave that to me. So I need one of the three rhombus proofs. It's giving me perpendicular diagonals. Once I have the parallelogram with perpendicular diagonals, I can say it's a rhombus. A rhombus is a parallelogram with perpendicular diagonals. So that's what you ultimately need to get to in order to prove the rectangle, rhombus, or square. We'll just take a look at one more here. To prove it's a square, it needs to be a rhombus and a rectangle. It's already a rhombus, so it needs a rectangle proof. I told you that the diagonals were congruent. Once it's a rhombus and it has a rectangle proof, I can say it's a square. A square is a rhombus with congruent diagonals. It's not going to be that simple. That's the mini proof version, but that's how it's going to end. Once you have a parallelogram and you have a rhombus proof, it's a rhombus. Once you have a parallelogram and a rectangle proof, it's a rectangle. So we move to the 4-point questions. And again, instead of writing this all out, if you're going to get this right, it's really going to be more conceptual. You're going to have all the basics down. We're going to have to prove triangles are congruent. We're always proving triangles are congruent. So it's pretty obvious to me which triangles I'm proving are congruent. I've got this one, and I've got this one. So I just do my proof. I take my givens. I got some perpendicular. So let me see if I can blow this up a little bit. I've got some perpendicular. So I've got right angles. That's one thing. I've got CECF. That's two things. I'm out of givens. I look for vertical angles, reflexive property. There's reflexive property. There's three things. State the triangles are congruent. And you can see the proof over there. I got my right angle. I've got my given. I've got my reflexive property. I got my triangles are congruent. Now that the triangles are congruent, I want to use CP/CTC to get one of the rhombus proofs. So I either need diagonals are perpendicular, diagonals bisect the angles, or consecutive sides congruent. So I look at the picture. There's no diagonals in this problem. If there's no diagonals in this problem, the only thing I could possibly do is consecutive sides congruent. Are the consecutive sides of the rhombus corresponding parts of those triangles? And the answer is yes. So I can state that BC is congruent to DC because those are corresponding parts of those triangles, and they're also consecutive sides of the rhombus. So I go to my proof. I say that BC is congruent to CD because of CP/CTC, and those just happen to be corresponding parts of those triangles. And now that I did that, I have a parallelogram because that was given to me. I have consecutive sides congruent. A rhombus is a parallelogram with consecutive sides congruent, so I can state it's a rhombus. That's how you do these. It's a lot of conceptual understanding, and you have to understand how to do your proofs. You're going to prove the triangles are congruent using the stuff we've been doing since October. Once you have that, you're likely going to have to use CP/CTC to get one of the 3 rhombus proofs or one of the 2 rectangle proofs, depending what the problem's asking for. Let's take a look at number 2. It ultimately wants me to prove that ABCD is a rectangle. So first I need ABCD to be a parallelogram. It's not, so I have to get there. It's telling me that BC is parallel to AD. Okay. I'm going to most likely have to prove triangles. I'm going to have to prove triangles are congruent. Is there any information for me to get the parallelogram right now? No. So I'm going to have to prove the triangles are congruent the same way I've been doing it since October. Since I have parallel, I have my alternate interior angles are congruent. I've got right angles from the perpendicular in the givens. I'm out of givens. Reflexive property, I have angle, angle, side. The triangles are congruent. Now remember, my first goal for a rectangle is to prove the parallelogram. I already have this pair of opposite sides parallel, so I need either another pair of opposite sides parallel or that same side congruent. Well, since these triangles are congruent, I can state that these sides are congruent through CP/CTC. Once I have that, I have one of my 5 parallelogram pictures. I can state it's a parallelogram. So that's 7 and 8 here. I use CP/CTC to get those pair of opposite sides congruent, which makes it a parallelogram. Now, for it to be a rectangle, I need one of the rectangle proofs, either congruent diagonals or a right angle. Well, I do see one diagonal, but I don't see both diagonals. So this one's out. So I need a right angle. And in fact, do I have a right angle right now? Yes. Did I explicitly state that anywhere in the proof? No. So I'm going to state that angle 4, and again, I label them. Angle 4 is a right angle. Perpendicular lines form right angles. I don't have to say perpendicular lines form congruent right angles. It's not wrong to do that, but I don't need it to be congruent to anything. I just need it to be a right angle. So now let's look what I have. I have a parallelogram. I have a right angle. A parallelogram with a right angle. Well, that's a rectangle. I can state it's a rectangle. A rectangle is a parallelogram with a right angle. That's how you do these. Again, you have to understand how to prove a rectangle, how to prove a rhombus. You have to prove it's a parallelogram first. To prove a square, it has to have the rectangle proof and the rhombus proof. And of course, you have to have an understanding of proofs in general in order to do it. We could take a look at one more. I feel like 3 is probably the easiest of them. Let's just quickly talk about it. In fact, it's right here. It wants me to prove it's a square. Since it's telling me it's a rectangle, I need a rhombus proof. I ended up using consecutive sides congruent, using CP/CPC from proving the triangle's congruent. And finally, it's telling me that ABCD is a parallelogram. It wants me to prove that BEDF is a parallelogram. So I'm going to have to prove that is a parallelogram first, BEDF. I can see that these sides are corresponding sides of those triangles. So I'm going to prove the triangles first. It's pretty obvious to me which triangles I'm proving. I've got these red triangles. Since the big thing is a parallelogram, I have opposite angles congruent, opposite sides congruent. I've got some perpendiculars. That gives me the right angles. That gives me the triangles congruent. Once I have the triangles are congruent, I can use CP/CPC to give me this. So that's one pair of opposite sides. I need another pair of opposite sides. This part is tricky. To get the other pair of opposite sides, well, since the big thing is a parallelogram, these are congruent. Since the triangles are congruent, these are congruent, and I can use subtraction property to come up with this. And if you want to see what that looks like in the proof, you can see that whole process here. Let me just zoom out a little bit so we can see the picture at the same time. I stated that BC was congruent to AD. This whole process here. Then what I was subtracting was CP/CPC, and then I did my subtraction property. Now that I had the parallelogram, again, I have one of my 5 parallelogram pictures. I state it's a parallelogram. A parallelogram has whatever 2 things I proved. So now to prove it's a rectangle, I need one of my 2 rectangle proofs, either congruent diagonals or a right angle. There are no diagonals in this picture. There are certainly right angles. I never stated that one of these was a right angle. In fact, it's actually not right. It should be here. BFD is a right angle. I said BFA. I should say BFD is a right angle. Perpendicular lines form right angles. Once I have a parallelogram with a right angle, I can state that it's a rhombus. A rectangle is a parallelogram with a right angle. So, not simple, but you have to understand that to prove a rectangle, I need one of my 2 rectangle proofs. Oops. To prove a rectangle, I need one of my 2 rectangle proofs. In order to prove a rhombus, I need one of my 3 rhombus proofs. Prove a square, I need one of each. And again, it must first be a parallelogram, and then you have to be able to apply the proofs to it. That's it. Practice it. That's it. Goodbye.